Okay, this is the grade 8 algebra warm-up. We have 4 questions here in a forfer. All of these are one-step algebraic equations, and they're all the same in that they have no coefficient, just a constant. So your expectation is you should be able to model these types of algebraic equations to solve, as well as solve using opposite operation. So the first question is x minus 3 equals 5. We have no coefficient, and if we did say we had a coefficient, our coefficient would be 1. But a 1 coefficient in front of the x is irrelevant, so we don't bother. So we use opposite operation. If I was to add 3 to both sides of this equation, I would create a 0 pair, and I would have isolated the variable. I would have left x by itself. And whatever's on the other side, in this case 5 plus 3, is the overall value, 8. So x has a value of 8. And I could check my answer by taking my original question, substituting the 8 where the x was, and seeing if both sides are the same, and they are. So the value of x is 8. If I look at this question in terms of modeling, we have this little thing right here, which is an x tile. We have these, which are negative 1s. Each of those integer chip is a negative 1. And the solid ones are all positive 1s. So if I was to add 4, or add 3, excuse me, to both sides, add 3 here, and add 3 here, I would create 0 pairs there, and I'd left with just x on this side. And over here, I'm too lazy to draw 8 ends, so I'm just going to 8 positives. And I would have the solution, which is the same as I had over here, x equals 8. Okay. In the second question, I have a little bit of a variance from my first. What's different about the second equation than the first? Evan? Well, right, I put my constant as my first term in my equation. And when I think of the picture over here, I'm going to do the picture first this time. If I look at the picture, I really have negative 4 here, and an x here, and a positive 3 here, right? That's really what I have. But what I want to do is I just want to get rid of my negative 4 thing there. Come on, there we go. I'm going to still do the same thing. I'm going to get rid of my constant by creating 0. I'm going to add 4 to this side, and if I do so, I have to add 4 to the other side, because in an equation, whatever I do to one side, I have to do to the other. I now have isolated the variable. I have an x, and over here, I have 7 of those left, so I have x equals 7. If I think about what it looks like numerically, I would add 4 to both sides. I'd create that 0 pair just like I did here. I'd be able to have x equals 7. Same answer. In your next equation, what's different about the third one? I have my variable on the right-hand side, and normally it's on the left. But it's the same thing. If you look at the picture here, I'm going to isolate this by getting rid of these. So I'm going to first, I'm going to take this, get rid of that. Over here. There you go. I'm going to put 5 negatives on this side, and I'm going to put 5 negatives on this side. And when I do that, that gets rid of my constant. And I end up with x on this side. 2 of these become 0 pairs, and I'm left with negative 3. Or negative 3 equals x. Or if I want to say it differently, I can say x equals negative 3. Both are the same thing. If I think about what that looks like numerically, I'm going to subtract 5 from both sides. I create this 0 pair, I get x. I now have the combination of 2 and negative 5. And if I have 5 negatives and 2 positives, I end up with negative 3. Okay? And the last question, I have my variable on the right-hand side, and I have my constant as my first term on the right. But all I'd have to do is add negative 3 to this side, add negative 3 to this side. So that's a 0 pair. I'm left with x. And these 3 negatives and these 3 positives are 0 pairs. Leave me with just 1. So 1 equals x, or x equals 1. Over here, it looks this numerically. A negative 3 to both sides. X is on the right. The sum of 4 positives and 3 negatives is 1. So x equals 1.